Hi everyone, thank you for joining us today. Our today webinar will be dedicated to PAS HYDROSYSTEM software and its newest, latest version, PAS HYDROSYSTEM 4.7. First of all, allow me to introduce myself. I'm Sergey Lisin. I'm PAS Support and Quality Assurance Engineer, and I will be your host during this webinar. Our today's agenda is following. Will start with some brief overview of PAS HYDROSYSTEM software. Then we're gonna talk about some new features of the latest HYDROSYSTEM version 4.7. And then we will have a question and answer session. So if somebody have some questions during this webinar, please write it down on our chat or on our questions and answer section. And after the webinar is finished, we will look at these questions and we'll answer them. So let's start about PAS software as a whole. We have a whole PAS suite, as we call it, of different software. We have a special software for fluid flow analysis. It's called HYDROSYSTEM. We have a stress analysis software for piping stress analysis, which is called PAS Start Pro. We have PAS Equip software, which is dedicated for equipment stress analysis. And we have PAS Nozzle FEM software, which is for junction stress and flexibility analysis of nozzle to shell junctions. And we have a lot of very good years of non-stop development and features. Our software is widely used in different industries. It's used for oil refinery industry, pipeline, gas industry, chemical industry, metallurgy, etc., you name it, for any different type of pipelines and equipments. And we have a very wide geography. So we are in more than 40 countries. We have more than 3,000 customers currently and still growing. We have 400 plus customers outside CIS. We have a lot of very good partners all over the world, high partners. And we have 17 PAS partners outside CIS. And today we're going to talk about PAS HYDROSYSTEM software. HYDROSYSTEM is what we call the fluid flow analysis software. This is where you calculate your pressure drops, your velocities, your flow distributions. This is where you size your pipes, size your pumps, and whatever. And HYDROSYSTEM is very experienced, as we call it, software. It was first introduced in 1977, so it's almost 50 years old. We're going to have anniversary in 2 years. It was blessed by piping hydraulic world-known guru guy named Adelchik, after of the famous work of the hydraulic resistances workbook. And currently, HYDROSYSTEM is used by more than 600 companies worldwide. And we consider it as an ideal tool for day-to-day simple calculations, operations in designing of any piping systems. In HYDROSYSTEM, you can calculate, first of all, a steady state flow, and perform heat and hydraulic analysis for this type of flow, and for various types of fluids, for liquids, for gases, both ideal gases, real gases, for gas-liquid mixtures, for gas-liquid-liquid mixtures, for liquid plus solid mixtures, aka slurry, settling slurry flow. Also, HYDROSYSTEM is capable not only calculating the steady state flow analysis, also HYDROSYSTEM is perform surge analysis of transient liquid flow, which we call water hammer calculation. And HYDROSYSTEM is suitable for piping systems of any complexity, any type of pipeline. You can easily calculate it in HYDROSYSTEM. In HYDROSYSTEM, you can solve different calculation tasks because hydraulic calculation is a thing that is done for different tasks. For instance, we have an upstream and downstream pressure drop calculations. So if you know what your inlet pressure, you can calculate what the outlet pressure will be, and vice versa. If you know your outlet pressure in your piping system, then you can calculate what the inlet pressure should be. So your fluid will come with the requirements you need. In HYDROSYSTEM, you can calculate flow distribution, you can calculate sizes of the pipes, nominal sizes. And in HYDROSYSTEM, you can get very detailed calculation results, which consists of fluid properties, fluid velocities, pressure drops, etc., 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 on each and every piping component. So you will know what happens in each piece of your piping system after you perform the analysis. In HYDROSYSTEM, we have very strong and very wide integration capabilities. We have two-side interface with our other software, StartProf, for stress analysis. So if you performed stress analysis in StartProf, you can easily import your piping system from StartProf to HYDROSYSTEM, and vice versa. If you have a piping system in HYDROSYSTEM, you can export it to StartProf to perform stress analysis. Also, not only the piping system is transferred, also some additional data on the calculation results can be transferred. We're going to talk about it in a minute. In HYDROSYSTEM, we have the same interface with PCF files. So if you work in any software that supports PCF files, for instance, some SmartPlan 3D, Autodesk, AutoCAD Plan 3D, or other software, you can export your piping system, which is built in this software, to special PCF files, which can then be loaded to HYDROSYSTEM, to StartProf, and to different similar software. And vice versa. If you have piping system in HYDROSYSTEM, you can export it to PCF files to then import it to your own software where you wanted to perform some analysis or something like this. In HYDROSYSTEM, we have two-side interface with DXF files. So you can import DXF files if your piping system is drawn in some AutoCAD, MicroStation, or whatever. Or you can export your piping system from HYDROSYSTEM to DXF files to get this drawing of your pipeline. Also in HYDROSYSTEM, we have an import of neutral format files, which allows you to connect HYDROSYSTEM with different third-party software application. For instance, we have already built-in modules for import data from Aviva software, from PDMS, E3D, Marine, and from Revit and Civil 3D by Autodesk. And also you can write your own module which will import data from your software to HYDROSYSTEM via these neutral format files. And also in HYDROSYSTEM, we have an isometric generation module, which allows you to export isometrical drawings of your piping system into AutoCAD. So if you use AutoCAD, if it's installed on your computer, you simply press the button, HYDROSYSTEM, and HYDROSYSTEM exports all the data to AutoCAD, and AutoCAD builds a piping drawing for you automatically. In HYDROSYSTEM, we have a very flexible licensing system. So depending on your needs, you can buy several modules, which allows you to perform different types of calculations. So we have a separate module for isothermal steady-state flow analysis. We have a separate module for heat and hydraulic analysis. We have a separate module for nominal size selection, for transient flow analysis, etc., etc., etc. So if you want only this, and this, you buy only these three models. You don't need to buy the rest. You don't need to spend money for the thing you will not be useful for you, and get as cheapest price as possible for the software. And in HYDROSYSTEM, we have a lot of convenient tools that are always at hand. First of all, we have a lot of different built-in fluid properties and equilibrium libraries, which allows you to automatically calculate all the required properties of the fluid for hydraulic analysis, all the densities, viscosities, heat capacities, etc., etc., etc. Different libraries for different fluids. Altogether, they include about 1,600 of different substances, and you can calculate the substances and their mixtures with each other. Also, we have an integration with some third-party software, such as Simulus Thermodynamics and PVT-SIM. So if you have either of this software, you can simply call it from HYDROSYSTEM, press the button Simulus Thermodynamics, and Simulus is called, and you can specify your fluid using this third-party software. In HYDROSYSTEM, we have very strong capabilities of two-phase flow calculation, two-phase gas-liquid flow. We not only can calculate the pressure drops, the velocities, etc., etc. We can also calculate flow patterns for each piping component, and draw a special two-phase flow pattern map on which you can understand where your piping system is working and what to do if your piping system is working in not desirable, not preferred two-phase flow pattern. There are some very, very bad flow pattern gas liquid flow, such as slack flow or other types of intermittent flow, which can cause high loads on your piping components, which can cause vibrations. And if you can avoid it, it is good. And two-flow pattern map allows you to understand how to avoid this undesirable two-phase flow regimes, two-phase flow patterns. In HYDROSYSTEM, we have a special goal-seek analysis calculation. This is for sizing some flow control devices, pressure control devices. So if you need to calculate, for instance, pressure control valve or flow control valve, you simply set that I want to get here pressure of this value, what kV of this valve should I have? And this and a HYDROSYSTEM is automatically performs this analysis for you. In HYDROSYSTEM, we have a surge calculation, not only you can calculate how the pressure surge are traveling across this piping system, you can also visualize this pressure surge right on the piping diagram. So you can understand how this surge will travel, where they will be reflected from some nodes, combined with each other and whatever. And also, not only HYDROSYSTEM perform the analysis of these transient events, we can calculate forces caused by water hammer, caused by two-phase slug flow, forces loads that will act on piping component of your pipeline, such as elbows, T's, bands, etc., etc. Why do we need to do this? Because we can then export them to another software called StartProf for piping stress analysis. So you calculate this forces, loads in HYDROSYSTEM. You can then export it to StartProf. And in StartProf, you perform stress analysis using these loads. And the StartProf will tell you, is it okay for your piping system or not? Will it be moved too much, or it is allowable movements or something like this? And let's talk about what we have new in HYDROSYSTEM POS HYDROSYSTEM version 4.7. We have a lot of new features, and the first of them is we now have a function of calculating mixing two-phase fluids in one piping system with different compositions. So as you may heard in previous version in 4.6 in HYDROSYSTEM, we added capability to calculate mixing of different fluids with different compositions, but only for single phase flow, for liquids, and for gas flow. And now in HYDROSYSTEM 4.7, we have the same feature for two-phase gas liquid flow. It works the same as for one-phase flow. You can separate fluids, gas and liquid, for each inlet branch. So for instance, here you have one composition, here you have the other composition with its own flow of components, with its own composition. And what will happen at mixing, compositions and property of this phase will be calculated by the software automatically. And you can see the calculation results, what compositions, what properties of the fluid in each piping component. Allow me to demonstrate this feature to you. Here I have some example of such type of flow. Here we have a mixing of gas condensate mixture. It is a mixture of gas flow is set as a mixture of gas components, nitrogen, ethane, methane, carbon dioxide, etc. And the liquid gas condensate is set as pseudo components, so as an oil fraction. And we have a quite simple piping system. So here we have inlet number 1, inlet number 2. Then this flow is dividing in two parts and goes with two different ways. Here, part number 1 comes to node number 2, mixing with this flow, and then goes to node number 1. And this fluid goes via this bypass, via this looping, and then mixed with this fluid in node number 1. And then all combined, all together, they are coming to node number 6 over here. And in initial example, I have the same compositions, or the same composition of liquid and gas flow. So here I have a condensate, here I have a gas flow. And now I'll copy this piping system as a whole. I will call it with different compositions. And now let's assume that in one of this inlet, for instance, over here we have a different composition of gas flow. It's done very, very easily. So you can not only you can specify the flow over here for the pipeline, you can add your own pipeline, add your own fluid to each piping branch. So here for inlet branch for this one, I can add another fluid, or I can copy it from here if the composition is quite the same. So to make it faster, I will copy it from the pipeline over here. Yeah. Oh, sorry. Here. And let's say I have a bit different composition over here. For instance, here I have in here I have a methane of 96%. For instance, for this branch, the composition content of methane will be 86%. And I will add another component, for instance, I don't know, for instance, propane. Let it be propane. The rest 10%. So now in this inlet, I have different composition. We can visualize all the compositions over here. So if I go back to the piping system, I can see what type of fluids are specified here in input data. In input data, I have specified gas composition in this branch. In this, I didn't specify it, but no, let's add some fluids to it over here too, so we can see their compositions in the input data list. Yeah, it goes like this. So here in inlet number 1, we don't have propane. In inlet number 2, we have less methane, and we have a propane of 10%. And the liquid composition is the same for each piping components. So that's it. That's how you do it. Then you perform simple analysis. I don't know, heat and hydraulic analysis, something like this. Okay. And it goes like every other calculation. So the pressure drops are calculated, the velocities, etc., etc. And you can also view what compositions you will have in each piping components. So the liquid composition everywhere is the same for each branch, and the gas composition, let's look at it more closely. So we can see here that over here we have 0 propane, over here we have 10% propane. Then in these two branches, 4.4.1 and 4.2, I have the same composition, same content of propane, so the fluid flow composition not changed in here. And then after we mix these two fluids over here, in here we have a different fluid composition like this. So the small amount of propane will be over here. And finally, after this fluid will add to this one, here in this branch, we have the following fluid composition. So as I mentioned earlier, in every piping component, you will see how your fluid behave and what composition it has. You may seem that it is not really important, but sometimes it shows great difference in calculation results. For instance, if we compare then this calculation with calculation of initial piping system, where we didn't take into account this change in propane concentration, propane content of 10%, we can see that in the initial piping system, we need an inlet pressure of 10 megapascals, above 10 megapascals, and after we fixed this fluid compositions more accurately, we then know that the inlet pressure is not so high as required. So it's worth to take into account these effects at your calculation of the piping system. So if you deal with piping system with different fluid compositions, not only for one phase, single phase flow, but also for two-phase flow, gas and liquid flow, now in HYDROSYSTEM you can perform such analysis. Then another option, another new feature of HYDROSYSTEM 4.7 that I would like to discuss is we now have the ability to take into account steam traps that will take away all the condensate that is condensated in two-phase flow out of this piping system. So we have a special element which is called steam trap, and in HYDROSYSTEM it works like this. So the steam trap is some ideal valve that doesn't allow vapor phase to leak in the condensate line over here. The condensate is drained by the steam trap completely, so liquid won't go over here. Steam trap hydraulic resistance considered a bit negligible, and usually it is negligible, so you don't have to take into account it in a calculation of hydraulic calculation. And currently, we do not perform the condensate drain line calculation, which would happen in one of this, but we will add this in the future versions of HYDROSYSTEM. So currently in HYDROSYSTEM, you can model the output of the liquid phase from your two-phase gas-liquid flow. How it's work, how it's done, let's look more closely. I have an example of such piping system. Yeah, I have some steam line. Yeah, the steam piping system where in point number 1, let's visualize it over here. Over here, I have a steam with temperature of 175 degrees, and the steam goes from node number 1 to node number 78, or something like this. And it goes with flow rates of 3900 kilograms per hour. And I need to get the outlet pressure of 0.6 megapascal. The question is, what inlet pressure should I have in here in inlet of this piping system to allow this fluid with this flow rate go through this piping system? Initially, I have this steam line without any steam traps. Let's perform analysis of this piping system. Okay, it works like this. So here we have an inlet point, we have a steam with quality 100%, so it's pure steam with no liquid, no water. But at the end of the first pipe, this 215 meters, we have 2% of condensate. So 98% is in the vapor phase and 2% in the liquid phase. And if we go further in this piping system, we will see that in following components, following pipes, the condensation continues. So as you can see, the quality goes down, decreases, goes to this. It also decreases. And at the outlet of this piping system, we have, what do we have? We have a quality about 95%. So which means about 5% of our steam will condensate in this piping system. No matter how good it is insulated, we have insulation, but it's not enough to prevent this condensate from appearing. And now in HYDROSYSTEM, you can model such special components which will transfer your condensate out of this piping system. To show it to you, I'm going to copy this piping system as a whole. Okay, the full copy, and the copy, I will give it the name steam with steam traps. Steam traps, like this. And to model steam trap, you simply need to select node where the steam trap is located. For instance, I will have steam traps before each rise in this piping system. Usually the steam traps are located before some inclined or vertical pipes. Here I have a vertical pipes with upward flow. Here I have a vertical pipe. And here I have a vertical pipe. So before each of this rise, I will add a steam trap. To add it, you simply select the node, and we have a special component which is called steam trap. Simply press this button. Okay. And it's added like this. So as you can see, it looks like this. So here I have a steam, and then the liquid will go over here. What will happen with this liquid? We don't know. We will calculate it in a new version of HYDROSYSTEM. And let's add another steam trap over here. And another steam trap over here. Okay, done. So you simply add this special type of valves, and then you're ready to perform your analysis. Okay, let's calculate this piping system once again. And now it will be much more interesting. Look, first of all, we have not only one phase transition to two-phase flow, we have 4 two-phase transitions. So which means our fluid start condensating 4 times in this piping system. Interesting. Then we have some inflow outflow, which occur at different piping nodes. So let's figure out what is going on in this piping system now. So let's start with this pipe, the first pipe over here. As it was before, yeah, the fluid condensates almost the same it was before, about 2%, but then we have a steam trap which will take all the liquids away from this pipeline. And if I select this this piping component, we will see that the quality is once again equals 1. So which means that liquid moved away from this via this steam trap, and here we have a pure steam flow in this piping component, which again starts to condensate. That's why we have different various two-phase transitions, because steam once again condensates. Once again, condensate is forming. Let's calculate how much it will be. About 1.23%, something like this. And this amount on liquid will be moved away from this piping system on the following steam trap over here. So after this steam trap, once again, we have 100% quality. So once again, steam that doesn't, nothing but the steam goes through this steam trap, etc., etc. So after this, the fluid comes to the following steam trap, where the rest condensate formed once again removed from this piping system. And we can calculate the amount of removed this condensate and how it will affect the calculation results, how it will affect the pressure and other components. So if we'll compare this calculation results with previous piping system, here I calculated that I need 0.74 starting pressure to allow this component to go through this piping system. Then if we perform the initial piping system analysis, we will get that if we didn't take into account these steam traps, the calculation results will be a slight difference. So here we have a different pressure. That's why we need to take into account all those effects, how it affects the flow rate in this piping system and the whole hydraulic picture in this piping system. So if you calculate some steam lines or another vapor flow in piping system where vapor condensates, where liquid phase occurs, now you can model such devices, which is called steam traps, that will remove all the liquid phase from this piping system, starting with HYDROSYSTEM 4.7. And we have some new other features in our newest version of HYDROSYSTEM. One of them is we have an accent colors now in user interface. You may notice that when I showed you some calculation HYDROSYSTEM, some tabs in the object properties are now colored with different colors. Why? What's this type of rainbow for? Because HYDROSYSTEM is capable of performing different type of analysis, some isothermal flow analysis, heat and hydraulic analysis, water hammer analysis, etc., etc. And new users who didn't use HYDROSYSTEM before, they may not easily understand what tabs should be filled for this type of analysis, or what tab doesn't require for this type of analysis. That's why we decided to add different colors for different types of calculations which HYDROSYSTEM is performed. The red color for heat and hydraulic analysis, the green color water hammer analysis, the yellow color settling slurry flow analysis, and the blue color calculation using parameter selection, sizing of control devices, etc., etc. So if you see in HYDROSYSTEM interface that some tab or some cant of some tab is green, this means that this tab contains only those parameters that are required only for water hammer calculation. So for instance, if you don't want to perform water hammer calculation, you don't need to fill this tab. You can see that it's not for your analysis. All you need to fill is another tabs which are for your type of calculation. And if you see an uncolored tab, for instance, pipeline, or for branches, we have branch nodes tabs which are not colored. It means that these tabs are used for different types of calculation, not only for heat and hydraulic, not only for water hammer analysis, but for all the types of calculations which you can perform. So we hope that this will help new users to easier understand which input data needs to be specified in different cases, different calculations. And also in HYDROSYSTEM, latest version, HYDROSYSTEM 4.7, we have some other improvements. We have added a support of AutoCAD latest versions 2025 and 2026 for exporting isometric drawings. We made some bug fixes work, some minor issues with components and black holes input have been fixed. We improve the diagnostics of elevation mismatches in closed loops pipeline if you work with some pipeline containing closed loops. We have improvements in thermal analysis of uninsulated underwater piping system. We now perform this heat transfer to water from uninsulated pipeline more carefully, more accurately. We fixed some import issues of some archetypes from DXF. We have some issues in previous version of resetting the initial points in 2D mode. We fixed it, and we fixed some other minor issues. We'll always have something new to fix. And now let's talk about some useful links. I want to remind you that you can always download the latest version of HYDROSYSTEM from our website using this link or using this QR code over here, including the free viewer. So if you use HYDROSYSTEM and you want to show the calculation results to your boss or your customer or whatever, you can send them this free viewer. He will install it on his PC, and you can send a HYDROSYSTEM calculation file right to this customer, and he will be capable of opening it using this free viewer. Also, you can turn on the automatic updates of HYDROSYSTEM, and then the newest latest version will be loaded to your PC automatically at the next launch. And I want to remind you, if you're not a customer not user of HYDROSYSTEM yet, you can request a free trial, free 1-month trial using this link over here, or this QR code over here, or this link over here. It's absolutely free, it's absolutely functional, but only for 1 month. And for more interesting lectures and webinars, etc., visit and subscribe to your YouTube channel, where we always load all the new stuff we have regarding HYDROSYSTEM and other PAS Suite software. So thank you again. Thank you for joining us today. Hope this will be useful for you. And let's go to our Q&A, questions and answers section. So if you still have some questions on HYDROSYSTEM, you can write it in our Q&A section. So find this button, not chat, but Q&A section. It calls questions and answer or Q&A. I don't remember how to exactly spell here in Zoom. And write your question over here. Now, in a few seconds, we'll start to discuss all these questions.